We're given the vertical height of an object here, and we're given that with the function s of t, where t is time. And what we want to do is we want to find that average velocity of this function over a couple of different intervals. The first interval we're going to look at is the interval from t equals 0 to t equals 3. Now we can look over here on the graph and just get an idea of what we're looking at. When t is 0, we have our vertical position at 20, and then when t is 3, it's going to be awfully close to this vertex we have here. And so when we draw a line between these two, we can see we've got a really steep slope here. And the average velocity is going to correspond with that slope. So what we're going to do is we're going to say the average velocity is going to be the slope, which is our change in y over our change in x. In this case, we're going to actually have our change of s over our change in t, because our variables are a little bit different here. We have s instead of y, t instead of x. We're going to plug in s of 3 minus s of 0. And then we're going to plug in for the bottom, we're going to have our change of t, which is going to be 3 minus 0. And so we can plug in these values, and we can see our s of 3 corresponds to 65.9. Our s of 0 is 20, and that's all over 3. And we're going to get 15.3. Now in this particular case, this problem hasn't given us specific units. We can make some assumptions just based on what we know of gravity, but in this case I'm just going to leave units blank because we weren't given the units up front. Now next thing I want to do is I want to look at this interval from 0 to 1, and if I come over here on the graph, because this is such a steep graph, it's going to be kind of hard to see, but I'm going to draw it anyway. If I go from 0 to 1, and we're going to be somewhere near 45. And when I draw this line, it's going to be steeper than the line from 0 to 3. And so we would expect to find our average velocity to be greater than that 15.3 that we saw. But once again, our average velocity is just going to be, in this case, s of 1 minus s of 0 over 1 minus 0. That's our change in position over our change in time. Now our s of 1 is going to be 45.1. And then our s of 0 is 20. And then we have that all over 1 minus 0 is just 1. And so we get 25.1. That looks reasonable when we compare it to our average velocity for the first 3 seconds. We knew we were going to be steeper, and indeed 25.1 is greater than the 15.3. Now the tricky part is when we come over here and we actually have a 0 to h, where h is greater than 0 and it's a real number. So we want to find that average velocity for the first h seconds. We want an equation that we could plug in and say, okay, what's the average velocity for the first 5 seconds? We'd plug in 5 for h and find that average velocity. I could say 4 seconds. What's the average velocity for the first 4 seconds? And I could plug in 4 in place of h and find this average velocity. So I'm going to go ahead and I'm going to do the same kind of thing that I did in the first couple examples, but instead of putting an actual number like 3 or 1, I'm going to put in h. My average velocity is going to be s of h minus s of 0, all divided by h minus 0. That's just our change in position over our change in time. When I replace t with h in our original position function, I get negative 4.9 h squared plus 30h plus 20. That's my s of h. And then I'm going to subtract my s of 0, which is just 20, and I can put that all over h. And so now I can simplify this. My plus 20 and my minus 20 go to 0. So what I have here is I have negative 4.9 h squared plus 30h divided by h. Well, this can simplify further because I can see in this numerator that I can factor out an h like so, and h divided by h is just 1. It already told us that h is greater than 0, so it doesn't equal 0, so I don't have a problem with my denominator ever. And I end up with negative 4.9 h plus 30. And this is going to give me my average velocity over the first h seconds. So what's interesting about this is if I come over and I plug in 3, which was the first problem that we did, I should be able to get the answer that we had initially, that 15.3. Negative 4.9 times 3 plus 30, and I actually get that 15.3 that we got in our first problem. And I could do the same thing for the 1. I could plug in 1 in place of h, and I'd end up with that 25.1. This V average is going to be negative 4.9h plus 30. That'll be my answer.